When Eleanor, Bonnie, and Carl are calculating the slope of a line segment with endpoints of 15 and 8 and negative 10 and 6, their work is shown below. So for Eleanor, she said that you're going to take negative 10 minus 15 divided by 6 minus 8 is going to give you negative 25 over negative 2, or the negatives will cancel out and you get positive 25 over 2. Bonnie said that you're going to take 6 minus 8 over 15 minus negative 10. That's going to give you negative 2 over 25, or they just moved the negative down to the side and said that it has a slope of negative 2 over 25. For Carl, it is 8 minus 6 over 15 minus 10, which gives you 2 over 5, or a slope of 2 over 5 as a final value. Since their answers are all different, at least 2 of the students have made errors in their calculations. So what errors did they make? Well, if I'm looking at what errors each of them made, then I'm going to say that Eleanor used the wrong formula. She used the formula of x of f minus x of e over excuse me, y of f minus y of e, as opposed to y of f minus y of e over x of f minus x of e, which basically meant she put run over rise instead of rise over run when she was solving it. For Bonnie, she wound up using y of f minus y of e over x of e minus x of f, which meant that she didn't stack up the correct points on top of each other. The f's should stack on top of each other and the e's should stack on top of each other. And if we want to take a look at Carl, well, Carl wound up replacing the e point, or the second point, with positive 10 instead of the negative 10, which meant that Carl replaced the wrong x of f value. So because he forgot to use the brackets, he put the wrong number in there. So all 3 of them actually were wrong. All right, when we're talking about collinear points, 2 lines that exist on a plane can either be at an angle where A to B to C all wind up connecting, but the line doesn't continue on, so you can see that there is an angle or a shift here. You can have 2 line segments that are parallel and distinct, which means that even though they share the same slope, they run through completely different points. Or you can have ones that are parallel and form a straight line, which means that they have the same slope, no matter which points you go between. We call these collinear because it means that they're all part of the same line. So, if any 3 points, P, Q, and R, are collinear, then the slope of P to Q has to be the same as the slope of Q to R, which has to be the same as slope of P to R. If I take any of the points and combine them, then the slope here has to be the same as the slope here, which has to be the exact same as the slope here. So, if I have the points of 5 and negative 3, 2 and 6, and 7 and 33, and I need to prove that these points are collinear, then I have to figure out what the slope of AB is. I have to figure out what the slope of AC is, and I have to figure out what the slope of BC is. Going between all the different points, as long as the slopes are all the same, it is in fact collinear. So if I'm doing the slope of A to B, then I'm going to take the B points, 6 for Y and 2 for X, put them on top of each other. I'm going to take the A points, negative 3 for Y and 5 for X. 6 minus negative 3 is going to give me 9. And 2 minus 5 is going to give me negative 3, which means this has a slope of negative 3. If I'm going to AC, then I'm going to say that I have 33 on the top for Y and negative 7 on the bottom for X, minus negative 3 on the top for Y and 5 on the bottom for X, and 33 minus negative 3 is going to give me 36, and on the bottom 7 minus 5 is going to give me negative 12. 36 divided by negative 12 is negative 3. Looks good so far. And last but not least, I'm going to take 33 from my point C for Y and negative 7 for my X value at C. I'm going to subtract from that my Y value at B, which is 6, and my X value B, which is 2. And this is going to give me 27 over negative 9, which is also going to give me negative 3. And because they all have the same slopes, they are collinear. If I want to find the value of Y at point D, Y, that lies on the same line segment as AC, then I know that the slope of AC is going to be negative 3. And that has to be the same as if I took the points of D and A, because it's going to be the exact same slope, because they're going to be on the same line. So I'm going to say that Y, at D is just represented by Y right now. The Y value at A is negative 3. The X value at D is going to be negative 4. And the X value at A is going to be 5. Now, I'm just solving for Y. So, first thing, I'm going to simplify the denominator, and I'm going to say that this is going to be negative 3 is equal to Y, well, minus negative 3 is the same as plus 3, over negative 4 minus 5 is going to be negative 9. I'm going to multiply both sides by negative 9, and I'm going to state that, well, negative 3 times negative 9 is 27 is equal to Y plus 3. And then to get Y by itself, subtract 3 from both sides. Y is equal to 24. And there's my answer.